Hello students, this is the concluding lecture of the general mean value theorem, and we'll come to know that when we are using this mean value theorem for the expansion of fx, the how much will be the error in that. The linear approximation will drive the expression of linear expression, and we'll find the approximate value of some some values. In approximation, let fx be differentiable in at a point x not belong to dominant function. Dominant function fx. Then the linear approximation of fx is fx naught at x naught. The approximation at x naught would be of fx at x naught will be fx naught plus x minus x naught f dash x naught in the neighborhood of x naught. Let us suppose that the Rx is the error in this approximation. That is, when we approximated fx by the value fx naught in the neighborhood of x naught, then the error will be Rx, and this will be the difference of the value of fx minus fx naught minus this fx minus this. That is fx minus fx naught minus x minus x naught fx f dash x naught. We are discussing the neighborhood of x naught and the function differentiable in the neighborhood of this point. Now, if we divide both sides of this equation by x minus x naught, this we will get the value rx upon x minus x naught is equal to fx minus fx naught upon x minus x naught minus f dash x naught. If you take the limit of both sides x approach, means if you approach x naught from either left or from the right, you will get limit x approaches to x naught of rx upon x minus x naught is equal to limit x approaches to x naught of fx naught fx minus fx naught fx minus fx naught fx minus fx naught upon x minus x naught minus limit x approaches to x naught x approaches to x naught of x approaches to x naught of f dash x naught. So the value of this will be this derivative of the function at x naught. This will equal to, now if they take the limit, the error will come out to be 0. We should have shown that this error is 0. And the result second implies that Rx is small. Rx is the error. The error term is small if x is close to x naught, and in fact arbitrarily small as compared to x minus x naught modulus. This is Rx is small if x is close to x naught, and in fact arbitrarily small, very small as compared to x minus x naught. But this relation does not signify how small Rx is for a given x not equal to x naught. For that, let fx has second order derivative in the neighborhood of x naught. Okay, how small is Rx? For that, you will find the approximate value of error. How much this error is small? For that, let us suppose the fx as the second order derivative in the neighborhood of x naught. Then apply the Lagrange linear theorem to the function fx over the closed interval x naught to x naught to x, this closed interval x naught to x naught to x naught to x. If you apply this to the function, then with the help of Lagrange we did a point C, because if it's second order differential in the neighborhood of x naught. Therefore, the function differential that is continuous means this fx is f dash x satisfies the Lagrange generalization. So, uh, f in the neighborhood of this, we can write fx minus fx naught by the with the Lagrange generalization. Fx minus f naught is equal to x minus x naught f dash c. C belongs to f naught to x. Now, what will the error term then error term become? We'll substitute the value of fx naught here. value of fx not in this first, fx minus fx not here. So if substitute the value of this here, we'll get rx is equal to x minus x naught. So will this same here, x is common, is f dash c minus f dash x naught. Since fx satisfies all the condition of Lagrange theorem in this closure, x naught to c, x naught to c. So therefore, again we can apply Lagrange theorem. If f is second derivative, that means it's continuous. F dash x is continuous in this interval. So in the neighborhood of this will be, we can write f dash x f dash c minus fx naught is equal to c minus x naught f dash f double dash at c1. c1 for all x naught is less than c1 is less than c less than c x naught is less than c is less than x. Now substitute the value of this, then rx comes out to be, and Rx and substitute of this in this interval x naught to c, we'll get substitute here, we'll get Rx will be equal to x minus x naught c minus x naught f double dash c1. Now c, we are discussing in the neighborhood of x naught, therefore c minus x minus c and c minus x minus x naught and c minus x naught are completely close to each other. So we replace this by some larger value, so this will become r will become less than equal to, we replace x minus c by the larger value, because x minus c is less than x, therefore c minus x naught is less than x minus x naught. So x will be less, the x minus x naught less than x minus x naught fs f double s x1. So this is equal to, this will become equal to therefore rx modulus become less than modulus of second derivative f double dash second derivative f at c1 modulus this into x minus x naught whole squares. Modulus square one can put here. In case this is bounded in the neighborhood of x naught, it is bounded in the neighborhood of x naught, means there is a different value. So this implies f dash x f dash at f dash at x is just name for all x in the neighborhood of x naught. So substitute the value, then Rx comes out to less than equal to n into x minus x naught whole square. This is the error term. This is how we can find a problem based on this. Find the, this beautiful use of this Latin term. Find the absolute value of 166. So how to find this height? With decide function. Let fx is equal to root of x. In the interval we decided from this. Whose square we can find is 64 to 66. So a 64, a plus x 66, x comes out to 2. So f dash x is equal to differentiate this into half, x square minus half, this is equal to 1 upon x square. So this derivative does not exist at 0, 0 does not belong to this. This implies f does exist in this interval. So f satisfies both the condition of Lagrange in the interval 64 to 66. So there is a point, this is a real number theta, 0 less than theta less than 1, such that f a plus x minus f a is equal to h into f dash a plus theta h. Theta h, where theta is 0 is less than theta is 1. Now substitute f a plus x 66 is equal to f, so take the right hand side, f of 64 plus x is 2 to 1 by 2 root of 64 plus 2 theta 0 less than theta. Now theta is very easy. Uh, Now using this implies f66 is equal to 8 plus a root of 64 plus 2 theta. Now if theta is equal to, theta is from 0 to 1 open interval. So if theta is equal to 0, what is the value of this? Then this will be equal to, this will be less than 8 plus, because the value of theta is very small, small value means it will be decreased in the value. This will be 8 plus a root of 66 less than 8 plus 1 upon root of 64 plus 0. 8 plus 1 upon 8 is 8 plus 1. Then the value of 66, root 66 will be 8 1.5. Now theta is equal to 1, so 6 will be increased, 6 will be greater than 8 plus root of 64 plus 2, 8 plus 1.66 is equal to 8 plus 1 point. Now 8.23 from this sentence, from this equality, we can conclude that 8.132 is less than 6 less than 8.125. So therefore, it is arithmetic unit is values. It comes out to 8.124. Now again, find the approximate value of 0.02930. Again, we set the function fx is equal to third root of x. Interval is, we can find third root of 27, 0.237 equal to 0.3, 0.3, so 0.3, we decide to go third root to find, and next one we decide to this. So is 0.027, it is equal to 0.09, so h is equal to 0.002. So 0.02, and after x comes over 1.13, x squared minus 3 is equal to 1 upon x over 2/3. So now 0 does not belong to this. Belong to this. So the domain of this function is given if f dash x is all in except 0. 0 is not in this interval, so f(x) is differentiable in the differentiable in the open world open world 0.027 to 0.09. So if it is differentiable, that is therefore continuous. So we can apply Lagrange to the interval. This interval goes into 0.027 to 0.09, and it is between V to V plus H. So by the measure, f of a plus H is equal to is this, V plus H is this, f of a plus H is equal to f of a plus H into f dash a plus theta H theta. Now substitute the values because H, A, and H also. After substitution of their value in the functions, we got this thing. And now taking the value theta is from 0, teaching less than theta is 1, to take theta minimum theta is 0, so this will become, now again greater will become smaller, so it will become, this term will become greater. This is a root of 0.07 to 0.3 plus 0 point h is equal to 0.02 1 upon 3 of 1027 equal to 0.09. When we calculate simplified mathematical calculation, we got this equal to, and substitute the value of pf. Substitute the value is equal to 0.27. Okay, this 0.27, and this comes out to be, which is upon this, is equal to 270 is equal to 1.3 plus 0.3 is equal to 0.3 plus this is 0.3017114. Similarly, when theta is equal to 1, so this will become greater than this. Again, we have larger, so this will become smaller. So this is 3 point, substitute the value, makes the equation is equal to 0.3075. Now again, this is like this is the smallest value, smaller than this, and this is greater than this. This value is greater than 0.027 root, so like them, so arithmetic this value is to be arithmetic. Again, find the absolute value of sine of 31 degree and estimate the fx is again sine of x is interval is 30 31 degree, it connects to gradient 5 or 6 5 or 6 1 to 5 5 5 1 radians. Now theta is a is equal to 5 or 6, a plus x is equal to 5 or 6 for 5 unity, so h comes out to 1 5 unity, so f dash comes out cos of, and f dash is equal to minus sine of x. Both the function, this function definition hold all real numbers, this is for all real numbers, so sin x domain real numbers that are real numbers, so this is it is fx is confidence in the control real number, therefore confidence in this interval, definition is open interval, definition we have got this domain is all real number. Now both the condition of the energy will be satisfied in this interval. So if A plus H means 30 pi by 62 pi by 6 plus pi by 1. So in this interval, so they said this is equal to C is equal to how much? 5 by 6. 5 by 6, 5 by 6. This is equal to 6. Such that f of A plus H is approximately equal to f of A plus H into f of f dash C. You see, it's very close. See, this pi by 6 and pi by 6 plus it's very good value. So, not to calculate the value, we have simply substituting the reference to this approximately equal because we want to find the value of 31. So, approximately C is taken here. So, this is f of sine of pi by 6 plus pi by 1 t is equal to which component is approximately equal to sine of pi by 6 plus pi by 1 t cos of pi by 6. So, this is equal to sine of 30 we can simply 1 by 2 simply substitute the value and make calculations and we got is equal to sin 30 is equal to 515. The error will be equal to x minus x naught. X minus x naught is equal to again pi by 6 into the x minus x naught h square into f dash x. This is about how much c1 c1 it is bounded in the table of in this interval 5 by 6 to 5 by 6 to 5 by 6 plus 5 by 1. Boundary control substitute the method in this m is 1 so this is equal to 5 by 19 4 square into 1 is the estimate.